Okay, the last group of presentation is four gentlemen, Gerard, Ryan, Spencer, and Andy. Actually, they just did the same presentation 3 days ago. Yeah. And they won the third place in ESE Indiana conference. Okay. So let's give time to them. Yeah.
Good evening, everybody. I want to thank you for taking your time out of your day to come see our presentation. We are the structural design team. Our project is the Fort Wayne Downtown Arena. I'm Spencer Moon, and my team here is Ryan Allred, Gerard, Guell, and Andy Tran. This project would not have been possible without the help of our academic advisor, Dr. Mohammad Alhassan, as well as our professional advisors, Kurt and Dan from ERI, and our good friends, Corey and Michael from Elevatus. Getting right into things, we're going to run through an outline for our presentation. We're going to start off with the problem statement, followed by the location of our project. We're going to be setting up the proposed model, see some of that, and our design loads, which are going to be used to calculate our structural design. And lastly, we're going to be going into the material costs for the project, as well as architectural design. So getting right into things, the city of Fort Wayne has experienced steady growth, unlike several other cities throughout the nation in the past several years. The economy is changing from an industrial strength economy to a more service-based economy. And there's a lot of facilities in Fort Wayne that attract a lot of visitors from outside of town as well as tourists. One of those being the War Memorial Coliseum. The downside of having the War Memorial Coliseum is up north, which part of our project is going to be trying to attract people to the downtown area of Fort Wayne. As you can see from the figure above, we have a Memorial Coliseum as well as other venues more located up north of Fort Wayne, and we're trying to attract more people downtown to boost the economic growth of the city. Disadvantages of having the War Memorial Coliseum up north would be that, in fact, they have a monopoly on the area and they're able to choose whatever rates and venues to become available for their complex, as well as the facility is too large to create an exciting atmosphere for smaller events, such as the Mad Ants basketball games. The fact that whenever large events are able to come to the Coliseum, they're lacking proper equipment for television space, so whenever the Pacers are able to come to the Memorial Coliseum, they're not able to set up for television. The benefits of having a downtown arena would be able to host different venues that the Coliseum cannot currently accommodate. The advantage of having an arena downtown would enhance the downtown redevelopment, which would boost overall growth for the city, as well as provide more opportunity for events to happen in Fort Wayne, creating more visiting and tourism, which would boost better seating for small events, including Mad Ants basketball and other smaller concert venues. The benefits would include economical, fiscal, and employment opportunities for the city of Fort Wayne. The location found during the downtown redevelopment study would be, the opportune place would be in this lot across from Parkview Field, which will also be across from the Allen County Public Library and the Grand Wayne Center right here. And the proposed model for the city of Fort Wayne's downtown arena will be here. Whenever we began this project, we wanted to start out with just designing the basic arena for where the games would be played. But after consulting with our academic advisor, we decided to design 4 structures in that as well. And next is going to be Gerard designing the design list.
Thank you, Spencer. So to design this complex, we used design codes ASC710, AIC-14 for steel design, and ACI 318-14 for concrete design. And according to those codes, the design laws we have to follow to design this complex are the ones shown in the table. As we can see, it's mostly 100 pounds per square foot, except for the stage floors, which go up to 150, and the parking garage, which go down to 40 pounds per square foot. Also, we wanted this building to be a risk 4 category building, which are those kinds of buildings that in case of an extreme loading event happening, such as an earthquake or tornado, they should resist those loadings. And actually they should provide shelter to the population in case of those events happening. So in order to do that, the windows that we designed this building to resist are 120 miles, winds of 120 miles per hour speeds, because those are the highest speeds that they have ever been recorded in Fort Wayne, Indiana. You can expect that other buildings have the higher loads, such as the arena and the parking garage, followed by the commercial and the office division. When it comes to alternatives, we don't have too much variability because we're following the guidelines provided to us by Elevatus Architecture, but they give us freedom to actually consider any route alternatives that we would think will be more adequate. So the first one we considered was a triangular truss, which offers us wind bracing using the diagonal members of the truss, but it's not as aesthetically appealing as other shapes could be. So then we came with a concrete arch, which is much more aesthetically appealing, but in the downside, it doesn't provide space for any wind bracing. So what we did was to combine both alternatives and create a truss system, but with an arch shape. So we can keep both the aesthetic requirement as well as the wind load, the ability to support such big wind loads. So here we have the decision matrix, and as you can see, the truss system arch fits over the two other alternatives. Next, we have the developed roof model. We can see how we use the truss system, and we also implemented some more wind bracing to provide the building some bracing against wind blowing in this direction. As we can see, this is a structural analysis picture from winds blowing in this direction, and we can see how all the members in the elevators and stairwell cases resist those loads as it should be. Although this model performs really well with loading, we had a problem with serviceability because the roof deflected too much, exceeding the AISC requirement for deflection. So what we did was to add these small knee braces at the end of each column so that we could reduce the unsupported length between each column and consequently meet this serviceability requirement. Next, we have the stress ratio of the roof structure. The right colors represent members that are not as stressed, while the violet and red colors represent members that are more in critical regions. We will say, some people will say that this structural model is not efficient because most of the members are in the right region, But the problem with this structural model is that loads don't control, serviceability does. So most of the members located in the roof, they are not there to support the load, they are there to prevent the roof from deflecting or swaying too much. Here we have the arena floor layout. We can see it's a 3-floor arena. The floors are steel deck or concrete, and we also added some more wind bracing using the stairwells as well as behind the bleachers to provide extra bracing for the wind. But when it comes to the stress ratio, we can see how here most of the members are actually in the violet and green and red region because here loads control, not serviceability. Here is an actual picture of the two models, the floor and the roof models integrated together. Next, we have the parking garage. The difference between this building and the rest of the buildings in the complex is that the parking garage is actually a reinforced concrete building, not a steel building. So the diagonal bracing that we use in the other steel buildings couldn't be used in this reinforced concrete building. So what we did was to add this shear wall in the middle, which is actually going to brace the building against wind loads. And the reason why this shear wall is in the middle of the building is to avoid having any shrinkage or temperature problems, which will occur if the actual shear wall was placed in the edges of the building. Again, the stress ratio, we can see how most of the members are located in the violet and red regions, which means that, again, load controls are not serviceability. And now Ryan is going to walk you guys through the other two buildings of the complex.
Thanks, Gerard. Here we have the commercial edition, and in this area here, this is actually located at the southeast portion of the arena complex, and this is actually going to be the main entrance into the arena. So, at first we decided that we wanted to have this area to be a completely open concept, but the problem was that there was a deflection controlling in the wind direction, and in order to fix that, we decided to add beams in the lateral direction, as you can see here. And that actually dropped the deflection down to 1/2 inch. Another area that I would like to point out and show you is here in the front of the building. There's 3 terraces, and the bottom and the next floor up, those terraces have a 10-foot cantilever system, an overhang. And so on the third story here, that actually had a 20-foot cantilever system. So, and it's only a 40-foot beam, so the deflection was controlling there. So in order to fix that, what we did is we decided to take the columns below and run them all the way up and through. And to give them, and Andy was going to give them an aesthetic pleasing view. Here, as I said earlier, is the southeast portion here. But you can see here, as Gerard said, with the members here, they are actually much understressed, and so that's due to the serviceability and the deflection requirements through AISC. Then here's the office edition. The office addition consists of 3 areas. Not only is it the office area, it's going to be the loading dock along with the storage area for the arena. So an area that I would like to point out here is this part right here. So a problem that we had here was that was with the deflection from the wind loading. And so we only actually needed to put a very little bit of wind bracing there, and that fixed the problem right away. And then here we have 6 cantilevers that are here, and the problem with that was they kept failing, and they were originally a W18 by 35. And so in order to fix that, we had to increase them to a W21 by 68 and a W24 by 68. Also, another area here, you can see, is the same thing that I just talked about with the last part of this building, is the serviceability is controlling, and so therefore the stress ratio is much less. Here's the complete structural model, and this is facing the southeast side. And here is the commercial building along with the parking garage. And then here we're on the northwest side, and you can see the office building and the arena. So the most common structural elements that we have in this building for the beams are W18 by 35, while the most common column is going to be a W12 by 26. So for the structural material, or the structural cost of the material, we only wanted to look at the materials that we're actually using and designing for. We didn't want to look at the labor, we didn't want to look at the finishes and the doors. It's only strictly our own materials that we're designing for. So the steel approximately was about $3 million, while the concrete was going to cost approximately $1 million, for a total of $4.1 million. And now Andy is going to take over for the rest of the architecture.
Thank you, Ryan. This is our proposed architecture design. And as we see, this is the arena. This is the arena, parking garage, and this is the commercial addition where our 2 main entrances will be located, which are located right here and right here. And here is the outside of the arena complex. What you see here is the office addition. And we decided to make the first floor to be used as a locker area for teams to use, and the second and third floor to be used as office space. And behind the office addition is the storage area for the arena and the loading dock. Here's our floor plan. As you see, this is the arena, the office addition, the parking garage, and the commercial addition. And first, I'm showing you the arena. The 2 things I want to highlight here is that the seating capacity is approximately 7,000 seatings, and that the suites level is located on the 2nd floor, which is located right on here. Next is going to be the commercial addition. Here's the outside view of it. And after talking to the architects from Elevatus, we decided to use the first floor as the main entrance for the arena, and also be used for a ticketing booth and retail stores. And the floors above that to be used as restaurants and bars, so that visitors can take advantage of the terrace and the nice view of Parkview baseball field across the street. Here's what a restaurant and bar can look like alongside with the terrace. And as mentioned earlier, the office addition will be used for locker area for the first floor. And here's one of the models that we created for the locker room. Here's a meeting or conference room that teams can use. And finally, our last building, which is the parking garage, has 4 levels. And based on a feasibility study, they wanted approximately 120 to 150 vehicle parking spaces. And we were able to obtain that using 3 out of the 4 levels. So what we did for the first level is we were planning to use that as a restaurant or office space because it would be more appealing for people walking by seeing a restaurant or office space instead of a parking garage on the first floor. And here's what a restaurant can look like on the first floor of the parking garage. And now our group would like to show you a video of our design. This is downtown Fort Wayne. And the surrounding buildings is Allen County Library. Parkview Field right here. And the Great Wayne Center. And now we're zooming into one of the main entrances of our arena complex.
I have a question. For finishing, as Dr. Chen said before, like presented this project as part of the ASC Indiana section annual meeting, design competition. And we also got third place in the state in schools such as Purdue, Allred, Notre Dame, and Tran. And this wouldn't have been possible without the help of engineering resources with Dan, especially Dan and Kurt, who helped us develop our structural models. Elevatus Architecture with Corey and Michael, which provided us with the preliminary models, allowed us to help us develop them, and also even allowed us to come into their office and use some of the software. Also, Greater Fort Wayne, who was the organization that gave us first the information on this project, and also like to thank them for the help, for all the work they're doing to improve Fort Wayne. Also, Dr. Suleiman Ashur, the Civil Engineering Program Coordinator, Dr. Chen, our faculty for this senior design class, and finally, but not least, Dr. Mohammad. I want to thank him also, not just for this project, but also for the knowledge that he has given us in all our classes, structural analysis, concrete, steel, and by helping us break down pretty complex projects like this one, and always making everything look so easy. So, thanks a lot. And any questions?
I have a question. First of all, this group, is one of the best ever I ever had. They are really all mature and they did high quality work. Second, did Dr. Yunus influence you in any way for the color of the arena?
They just have a right taste. They have good taste.
Guys, we should change it to blue, please. It should be blue.
We want to make it also good for the Madams to play, as we said, and the colors are red and golden and gold, that's why.
One just question, winding, the wind loads. Were they looked at in all directions, or was it just one prevailing direction that the winds were coming from? So it's kind of just
Both of them, the height doesn't change for either of the sides, so that's why.
Well, I'm saying like the wind coming in, like use your building design to take wind from every direction, or was it designed
Yes, I mean, we design from both the perpendicular directions, and then it becomes like at an angle, it's like simple statics.
Yeah.
You were talking about your deflection. You had that initial 5-inch deflection. Is that under max loading, like when you're experiencing 120 mile an hour wind and all of that all together? Or is that just the dead load?
You mean for the roof, right?
What's that?
For the roof?
Yeah, for the roof.
For the wind, it's alright, as we were able to show, had like enough bracing for the wind. The problem was that since the columns are so widely spaced,
Such a span.
yeah, exactly. Then for the gravity loads, that was the problem. But we have the snow loads, like some light loads for the roof in case someone has to go out there and do some preparations. And the problem is that it was about 8 inches deflection, and the limit is 7 according to the AISC. And then by just putting these small knee braces, the deflection went from 8 to 4.
Okay.
And consequently, we're able to meet these requirements.
Great.
Is this also engineered for wind going over the roof and lifting out? Any consideration for that?
I mean, actually, the wings should go under the roof. Yeah.
But it's the curved roof like an airplane.
Yeah, exactly. But in the airplanes, like the way it goes up is because like the actually wing goes under the roof and creates like uplift forces. In this case, can you go back to the an arena model? So like in our, that would be a problem if this was like open space. So actually, wing could come under and then push up and get
I'm
uplift.
concerned about the air going over the top.
Yeah, that's only going to create downward forces. So there's no uplift going to go to that.
So what you're saying, the draft, what he's saying about the draft?
Oh,
after
in the
this one?
friction, like pulling it out that way?
Yeah, the draft when the wind comes.
Yeah,
will it lift the
like, so you mean like wing going this way,
Yeah,
and like
yes,
kind of
yes,
dragging
yes,
it, and
yes.
like overturning it?
yeah.
I mean, it does actually like recreates all the wind cases, and it was like, as I said, like that was taking into account like wind from like acting all the way here to downward, so it should be fine for that. I thought you were saying for wind actually coming under the machine.
No,
I'm sorry about that.
I know we've had gymnasiums in the state where the roof just sucks right off the building there.
No, it should be good for that.
I like this.
Can you just say that how much the span for people to know this between the
So between the inside length, it's 2
To have it down there. The question is, did you consider cost? And if not, the other question I have, what is the probability or the chance to have this one really built in downtown?
For the total cost, we don't exactly have quite enough time to do the entire total cost of the building. I mean, if we had maybe another year, we could probably do that.
We can't do that easy.
No. So with that being said, no, we couldn't take the entire cost into it. The probability of this being completely done with our design, I would probably say not, because there's so much that can be changed to it to make it completely different. I mean, they may want it to be completely different than what we saw. And I mean, this is kind of a bit of our vision, or our vision, as long with Elevatus.
My question is, will the city really considering this one to be built, or just basically this is a kind of
This
exercise?
is an actual project that's possibly going to be going through downtown.
Oh, thank you.
Just have a comment and a question. Congratulations to the 4 teams for your accomplishment. You should be proud of your accomplishments. My question, which is you did a wonderful job, but I just want to see where my tax money is. What is the average attendance and who's going to play in this arena?
We have several local teams, not only the Mad Ants, but also it's going to be used for possibly high school basketball games, as well as other events and concert venues, as well as roller derby. I believe that was one of the options, to be able to have Fort Wayne Derby girls.
And it cannot be done at the Coliseum, you said?
They have been done at the Coliseum currently, but the fact that the Coliseum is so big and so large, whenever they have games inside there, it feels like it's an empty arena, even when they do have several thousand people in there.
What's the capacity for this one?
We have about 7,000 seats available for us.
And what's the average for the attendance for the Mad Anthony game? If it's not a free ticket?
Just go to 5,000 people, roughly. But then
Has nothing to do with you, obviously. You're not making that decision. I'm just trying to find out where my tax money is.
What's the capacity of the Coliseum now? What's the capacity of the Coliseum?
13,000.
This is half the size of the Coliseum.
13,000.
But they can change it to 5,000 easily.
Yeah, let's maybe have to go all the way up. And
But anyway, that's not your problem. I just filed my taxes last week.
It's a little late.
I just have one last question, just for Andy. So, like, I know you made all this in modeling software. Like, what all is the software that you use? And I know you put a lot of time into it. How much time would you say it took to make the video?
Video took like 4 or 5 hours. Editing and slowing down.
The modeling.
And the software?
Software took 200 hours.
200 hours or more. They spent like 800 hours in 3.5 months to develop this. I'm not sure you have to. That's all.
Well, this is our hours for our entire project.
In less than 3 months and lots of time.
Well, winning a third place in the state, it takes a lot of hours. You know? Congratulations on that one, too.